All right. Welcome to the couch time. You're stuck with me, though. The one that got out of that escape room. The one that seems to know everything, right? Welcome back to another edition of Couch Time. We're going to handle this a little bit differently. This little question and answer segment. A lot of you have been asking so many questions, so I thought I'd turn this into a little Q&A. So let's get to it. First question coming right at you. Let's see what we got here. Our first question is, what is the difference between units and square units? Let me explain. That is a great question. What's the difference between units and square units? Let me explain this. We use units to measure lines or the edge of a figure. It has no thickness. It's just a line. We use units to measure length, width, height, perimeter, things like that. Think of units like a tightrope. Right? You could stand on it, but you can't lay down on it. It has no thickness. It's just a straight line or a curved line, but it's just a line. That's what a unit is. Some examples of units you might be familiar with are inches, feet, centimeters, yards, meters, kilometers, and miles. Those are all units of measure. So for finding area, we're not looking at just a thin line. We're looking at the whole inside, all of it. That's the area. So what's a square unit? Because that's what we have to use. A square unit is not a line. It is a square with the same length on all four sides. This is a square unit. A square inch has side lengths of 1 inch. 1 inch, 1 inch, 1 inch, 1 inch. So we're not just measuring that line there, we're measuring all of this. It's a complete area. And you would take length times width and you would get 1 square inch. And we'll explain that in coming lessons there. So that's a square inch. So we use those square inches or square miles or square feet, depending on what you're measuring. If I wanted to find the area of a rectangle, I need to find how many of these square units fit without overlapping and with no gaps between them. So if I have this rectangle down here and I want to find out all of this, what's inside all of it, not just the edges, but what's inside of the entire, how much space this takes up, I would take my square units, and these are, let's just say these are square inches. And I'm going to see how many of these square inches can fit inside here. So that's 1 square inch, 2 square inches, 3 square inches, 4 square inches, 5 square inches, and 6 square inches. So I could say that the area of this rectangle is 6 square inches. So we can get different units or square units as long as the length and the width and as long as it's a square. So think about this. Every unit of length can be made into a square unit as long as the sides of the square are 1 unit of that measurement. So for example, a square foot, 1 foot by 1 foot. That's 1 square foot. A square foot is good to find the area of a room in your house or the area of a patio or a deck. It's much larger than a square inch because an inch is smaller than a foot. But we can get even bigger. A square mile. A square mile, again, 1 mile by 1 mile. So this is a square mile. Obviously, a square mile is much bigger than this square that you're seeing here, but this is just representation of it. A square mile is good to measure the areas of larger areas like cities, towns, states, countries, things like that. So hopefully that can help you understand there's a square unit and just a unit. All right, that was a great question and a great answer, wasn't it? Question number 2, another awesome one coming right from the inbox here. There you go. Next question right here we've got. How can you find the area of plane figures? Oh, that's a great question. Let me dive right back into it and explain it right to you. Oh, That's another great question. So how can you find the area of a plane figure? Well, let me give you this question, this little example here. Let me show you this question here. So imagine this. Danny is placing tiles on the floor of an office lobby. Each tile is 1 square meter. The diagram, which is this here, shows the lobby. What is the area of the lobby? Well, see, finding the area of a plane figure can be as simple as just counting our square units. This model here helps us. If you see here, I've kind of blown this model up a little bit down here. It's hard to see it over there, but this right here is this piece right here. And each of these squares are square meters. So it can be as simple as just counting up my square meters. 1 square meter, 2 square meters, 3 square meters, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this would be, pick it up here, 12 square, I can just abbreviate that, meters. It's sometimes can be as simple as that, and some of your work will be as simple as that, but sometimes it can get a little challenging, like this question here. Angie is painting a space shuttle mural on a wall. Each section is 1 square foot, so each of these pieces is 1 square foot, and that means it's 1 foot by 1 foot. Here's the question though. The diagram shows the unfinished mural, so right down here. Here's the question. How many more square feet has Angie painted than not painted on her mural? So you would have to find how many painted and how many are unpainted. And if I did that, I'd count the painted as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 square feet that are painted, minus, because it's how many more, how many are unpainted? 1, 2. So there's 2 that are unpainted. So how many more square feet has Angie painted than not painted? So I'd subtract minus 2 square feet, and that gets me 16 minus 2 is 14 more square feet. So sometimes you have to take that and apply what we're learning. Now it can get even a little more challenging because we need to start thinking about the different sizes of our square units. Check this question out here. You measure the area of a tabletop with blue unit square tiles and green unit square tiles. So blue and green. Which unit square will give you a greater number of square units for the area? So if you had a unit square and you had a tabletop, let's just say that's like this, which of these unit squares would you have to use more of? Well, I'd have to use more of the smaller pieces to fit this area. So because the green unit squares are smaller than the blue ones, I'd have to use more. So we have to start thinking about the size of our unit squares too. So it can be as simple as just counting, but sometimes we have to apply it a little bit more. Hopefully that answers your question. Now that was a great explanation, wasn't it? All right, time for the next question, because a lot of you have been asking all about this, like, oh, I see it, I see the array in there. Yeah. So next question is, how can we use multiplication to find the area of rectangles and squares? Awesome question. Very good. Hey, let me dive right back and explain this. Oh, all right. Yeah. So yeah, you can multiply to find area. Sometimes you start to see it, and maybe you have seen what these things are down here, right? You see these areas, especially finding the area of a rectangle or a square. You can't multiply for every figure, but square ones we can, and rectangles as well. So maybe you're starting to see these look like what we did in multiplication. These look like arrays, right? Do you see that, like this right here is 2, and then 1, 2, 3, 4, 5, 6, 7. So it's like 2 by 7. So you think that you can multiply 2 times 7 to give you your, and this is in square feet, your area of 14 feet squared. That's a little 2 up there. So that's what squared looks like in different math terms. And so again, look here. 3 by 1, 2, 3, 4, 5. 3 by 5. What's 3 times 5? Well, it's 15 feet squared. So instead of trying to count these, because you might start getting bigger figures to try to count 1, 2, 3, 4, you might see that, oh wait, you know what, I know this multiplication. Check these out there, because these are even bigger down here. And it says each of these is 1 square meter. So that means that these are square meters. But look, it works the same way. Just count them up. This is 4 by 1, 2, 3, 4, 5, 6, 7, 8. 4 by 8. So I do 4 times 8, I get 32 meters squared. So hopefully you've been practicing your basic facts with multiplication and division, because this is really going to help you when you get to these here. And one more here, 3 by 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 by 9, 3 times 9 equals 27 meters squared. So yeah, we can use our ideas of multiplication. Great idea, great observation. I might see a question like this, right? If I have this figure here, ooh, didn't mean to do that, but if I have this figure here, right? Colleen drew this rectangle, and it says to select the equation that can be used to find the area. Well, we can have different equations that might work, and multiplication and addition could be used to help us find these here. Now, I'd get my side lengths first. 1, 2, 3, 4, 5, 6. This is 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 6 by 9. I can use any variation of that. If you remember from multiplication, 9 times 6, yeah, that would work. If I have, it's the same thing with repeated addition, right? If you have 6 groups of 9, 9 plus 9 plus 9 plus 9 plus 9 plus 9, that would also get you there. But if you look here, 9 plus 6, that won't do that. That's not the same as multiplication and repeated addition. 6 times 9, that would work, because that is the one of the properties of multiplication, the commutative property, just flip-flopping your factors. But down here we have 1, 2, 3, 4, 5, 6 sixes. That wouldn't work, because you'd have to have 9 sixes for it to work. So sometimes you have to solve these out to find it, but this is an application of it. So remember, your multiplication can also help you finding our area of rectangles and squares. It doesn't work for all plane figures, but it does work for rectangles and squares. Great job. Did you know? So did you know that when you dial a phone number, the first 3 numbers are called the area code? That's right. All the home phones that are connected to your house are part of an area code. So if you live in this area, you would have either an 878 or a 412 area code. If you live outside of that, most of us would have a 724 area code. And then an even bigger area, this 814. So it all depends on where you live. Now, cell phones are a little bit different. These are just the phone lines that are connected to your homes. So, an area code. Now you know. Well, now you know. All right. Well, thanks for joining me on this little Q&A. Those guys just found out that I made this video without them, so they're not too happy with me. So, hey, good luck with your work. I gotta go. Here, go. Okay, ready?